Hey there. Welcome to Script Savage, the place where we break down programming concepts and make them savvy. Today, we're diving deep into one of the most powerful data structures in Java, the hashmap. Whether you're just starting with Java or brushing up your skills, you're in for an insightful journey. Let's get started. So, what exactly is a hashmap? In simple terms, it's a data structure that stores data in key value pairs. Imagine you have a dictionary where you can look up a word, the key, to get its meaning, the value. That's the concept of a hash map. Hash maps are super efficient for lookups, insertions, and deletions because they use a concept called hashing. But how do they achieve this efficiency? Let's dive deeper. Internally, a hash map in Java is made up of three key components. 1. Buckets. These are like slots in a table where data is stored. 2. Hashing function. This converts the key into a hash code to decide which bucket to use. 3. Nodes, or entries. Each node contains a key, a value, and a pointer to the next node, used in case of collisions. When you insert a key value pair into a hash map, here's what happens step by step. 1. Generate hash code, the key's hash code. Method is called to generate an integer hash code. Second index calculation. The hash code is mapped to an index using this formula. Index equals hash code percent number of buckets. 3. Store the entry. The key value pair is stored in the bucket corresponding to the calculated index. Now, what happens if two keys end up in the same bucket? This is called a collision. Hashmap handles collisions using something called chaining. In chaining, each bucket is a linked list. If two keys hash to the same bucket, they are stored as nodes in the list. The hashmap will traverse this list to find the correct key during lookups. When you call getKey to retrieve a value, here's what happens. 1. Hash code generation. The key's hash code is generated. Second index calculation. The index is calculated using the same formula. 3. Traverse the bucket. The bucket at the calculated index is searched. If there's a linked list, it traverses the list to find the key. If the key exists, the value is returned. If not, it returns null. Hash maps are widely used because they provide 1. Fast lookups. O1 on average for get and put operations. 2. Flexibility. They allow null keys and values. 3. Ease of use. The API is straightforward and beginner-friendly. However, remember that hashmap is not synchronized, so it's not thread-safe. For multi-threaded scenarios, you might want to explore concurrent hashmap. One last thing, resizing. As more elements are added, the hashmap might run out of buckets. To handle this, it automatically resizes itself by doubling the number of buckets. This process is called rehashing, where all the existing keys are rehashed to fit the new bucket size. And that's the internal working of a hashmap in Java. We covered its core components, how it stores data, handles collisions, retrieves values, and even resizes itself. If you found this breakdown helpful, don't forget to like, share, and subscribe to Script Savage. And if you have any questions or want me to cover other topics, drop them in the comments below. Keep coding, stay savage, and I'll see you in the next one.